40.
I will not. Media notebook.
You also do need your classwork notebook. Let's turn to the next available page. We're going to title it Stretching and Shrinking 3.2. Stretching and Shrinking 3.2. If you will put your binders on the floor under your seat, that'll help us out. If you get both of those things out, look just like Josh's desk, like Chester's desk, like Emilio's.
Like Terrence's desk.
Oh, Terrence needs to open his book though. Page 40.
Like Terrence's desk.
Alrighty. Guys and girls, we talked about tessellations the other day. And on the top of page 40, there is a tessellation with some birds. Take a look.
Oh, I've seen that on page 40.
Now, when you learned about tessellations before, you know that any triangle will tessellate. But tessellations aren't reptiles necessarily. Sometimes we can have a shape that tessellates to form a reptile, but a reptile has to be that same figure enlarged. And so, right off the bat, think about this question. Will every, instead of shape, let's just think about triangles. Will every triangle reptile?
No. Yeah.
Think in your brains.
No.
All right. We're thinking about triangles. Raise your hand if you think every triangle will reptile.
Yeah. Yeah. No. Wait, yeah.
All right, just a couple. Only 4 out of our whole class of about 18. So when we're thinking about this, we're going to keep that in mind for as we go through.
I'm on both sides.
You're going to be dealing with 3 different triangles today. One is a right triangle. It has a right angle in the corner, and the side lengths are a little bit different. So when we look at this guy, the one you're going to be dealing with has side lengths where one's shorter. That gives you a basic idea though. It's going to be blue today. We also have an isosceles. An isosceles triangle. And then we have a scalene. Raise your hand if you can tell me the difference between an isosceles and a scalene triangle.
I know.
Isosceles is acute angles.
Acute angles, possibly.
Oh, I know.
Same.
I know.
The same degree.
The same degrees. So we have a couple of corners with the same degrees. What else? Kayla?
The alien has sides.
No equal sides. We've got a really, really long one, a kind of long one, and a shorter one.
An isosceles has all same side. No.
The isosceles that we're dealing with today, guys and girls, is a little bit better than the one up there. It looks like this. Is the bottom the same length as the sides on top?
Well, on that it does.
It does, I agree. That looks more like an equilateral, so that's not a great example. So this one's isosceles. It's got a longer bottom,
Sides.
2 equal sides.
Yeah.
First shape I'm going to give you, I just want you to play around with a little bit. I'm going to first of all give you the right triangle. It is blue, and I want you to just play around with your table mates, because you're going to stay on the same part of the same problem today, with your table mates to decide if this right triangle will reptile. So I'm going to give you some blue triangles. I'm not going to give everybody the same amount. I'm putting them right in the middle. If you're far away from your table mates, you might need to move a little bit closer so that you can touch the shapes too. Today, as you describe and work in your group, it's really important to point and to move. Touching these
It
shapes.
made a rectangular.
Oh, you're very excited. Please listen to the rest of my directions. Oh, I gotta wait. Make sure that everyone at your table group is participating equally. Meaning, if someone's not touching these shapes, you ask them some questions. What do you think? When you figured out whether this right triangle will reptile, we're going to go on and look at a scalene. We're going to look at an equilateral. And your job is to answer questions A through C. Which questions do you have to answer?
A through C.
Oh, let's try that one more time. Everybody this time, which questions do you have to answer?
A through C.
All right. I'll be coming around, and we'll pause in a little bit to talk a little bit more. Go ahead.
They keep on making rectangles.
I made a big one.
Oh my god, these look like my kids.
No one's going to make this shape.
Whoa, you can make a five-sided shape.
That's cool. Is that a right triangle? No.
Look at that. It's isosceles.
Right now, it could either be an isosceles or an equilateral. We'd have to measure.
I think it's
What could he do? What could Joe do to make it into a right triangle? Or do you see a right triangle in there?
I don't think you can.
I think he can't, so be quiet. But I was
What do you
talking
think of what Joe's doing over there, guys?
You're annoying.
but I was talking to you still.
This has 4 sides right now. How many sides does a triangle have? Joe, would you push your stuff right up here and have the guys look at it with you? He's got the same thing you do, Tristan. How can we make that into a right triangle? What does it need?
that.
There we go, he's almost in.
What do you guys think?
He's almost in. Hey, Caleb.
Yeah? You think yeah? What do you think Joe needs to do to make that?
Together to
All right.
How did I make that?
You guys are onto it. You can. How is that triangle different?
Smaller?
How your triangle? Oh, there we go. You got it. All right. So will a right triangle work?
Yeah.
Okay. You can go up to my desk and get the pink equilateral triangles and try that. You can keep these at your desk.
They're all pink and stuff.
You cannot make the same shape out of it.
You can't.
Yeah, because I got you. You can make this part, like turn this up, and make a square.
Is that a square or a rectangle? Okay. What do you think, Dominique? Did you play in touch with them?
Okay, fine. But all the books together. This.
I got it.
Okay, so there's your rectangle. Now a rectangle has 4 sides, right? How many sides does a triangle have? Is there any way that we can make that into, to add some pieces?
See this shape? We're supposed to make a larger version.
How much wider does it have to be at the bottom if we double? 2. So can we move that up here?
Again, I don't think
Yep.
okay.
If we've got 1 represented here, how could we make that another times wider? Add another rectangle or triangle?
Triangle.
Okay, will you do that? We have to have this width though, not the long side. We have to have the short side.
I want to finish it today.
All right. Now, how much taller does it have to be?
Oh, we did it. We can do it.
Twice. So okay, so we need another one, right?
Don't show other people our
Do
shape.
we need it right there? Okay, we want, so we've got twice the width now. Now we need twice the height.
Right angle.
Can it be done?
This is bigger than the other.
Okay. Oh, we got it done.
This is bigger than the other.
How did you do it? It can be done.
I had to edit to go.
How much taller is this one?
Oh, yeah.
5'2".
And how much wider?
3.
They're cooler than you.
3. 1,
So this one doesn't count as width?
Nope.
Because it's
Counts
just
as
that,
height.
it just counts as height, okay. How many of the original copy fits inside?
4.
4.
Can I
All
get
right.
some more triangles?
I'll bring around some other triangles for you guys.
Ooh, I want
I made
more.
No.
What?
I'm missing a half.
Did you guys get it to work? You did? I'll have to come back to you in just a second. Did you guys get it to reptile? Alright.
No. The book down.
Okay, do that one.
Book down.
Start again. Draw what you did.
Oh my god. Yeah, I get all of them.
Most of them.
Yeah.
No.
Listen, guys, see what you think. That was the right triangle.
You sit over there and play with your butt.
Are you guys ready for another challenge? It looks like you got that isosceles one.
Now.
So why don't you clear it off to the side and just work with a scaling one for a little bit. I'll steal your equilaterals. I'll steal your fingers.
Wait.
That is a scaling, yeah. Go ahead and start answering the questions then.
Mr. The triangle fit together in a rectangle that is similar to the
Wait, read it out loud.
Did you get that right triangle to reptile?
Yes.
I'll be there in just a couple minutes, okay? You did. So now you're working with this isosceles. Did you set these books on the floor, please, Caleb? And when we're looking at this one, how should we start? Because instead of working separately at your tables, let's work right in the middle on the taller table.
Watch.
Here you go, Tyler.
It makes a fence.
Is that what we're working on today, making fences?
No, but it's also by making it.
Aha! It wouldn't quite be a tessellation, but I'm going to take them. Thank you. I'll take yours too. Thank you. Thank you, Lily. All right, so you've got to start down there. Will you bring those up here? How can we make a reptile out of these?
I got it. There's a square.
I don't know what questions to do. Remember, she didn't tell us. Alright, you guys done? This is. I like reading cards.
Is this going to reptile the way that Caleb's currently working on it? Are we going to end up with twice the width and twice the height, or 3 times the height, 3 times
What
the
are we
width?
supposed to do? Are we like writing?
You have to make this triangle. You have to make this triangle.
If this was a rectangle, we'd have it, right?
So we couldn't make that.
What do you guys think he should do?
Yes, I did. You did. Do it again.
Tyler, what are you thinking? Do you think this one will work? Can you get your hands in there too? Pause right there. We have a cool shape. Is this what we're looking for a reptile?
Nope.
No. Okay, so what should we do? How can we back up? How can we make this work?
A through C.
Let's start with just one. What does this guy look like?
Triangle.
Looks like a triangle, an isosceles triangle. We've got a width down here. If I line this up next to it, now what is my width of my new triangle? Double. So I need to double my height too. Ladies and gentlemen, eyes on me in 3, 2, 1. As I walk from group to group, I'm seeing that you're starting to figure out which one's reptile. But then I've heard people shout out, what are we supposed to do next? Guys, it's right here. Your job is to do A through C today. So if you haven't gotten started doing that, you need to.
We need the other squares.
You need some other shapes? Can you just make sketches of them, perhaps?
No.
You can, I have them, but if you're stuck, move on to that A. You can answer the questions without having all of those shapes.
So you made the right triangle with the right triangle.
Which
Is
of
that
these
what
are?
Mine.
Oh, she's speaking the other one.
Mine.
Oh, yeah.
Mine.
Hey, how many do we have to do?
I get these
How many shapes? All these?
Oh, yeah.
Oh, we did two.
You can almost make it. No, don't. You get stuck. But the blue one.
Copy that.
I did it! Daniel, how come you don't have your notebook open?
And then she
No. Dominique, what do you think of Terrence's idea? You don't know? Do you think that he's onto the right track, or do you want him to do something different? That first one wasn't a reptile on our warm-up today, was it?
No.
Why not?
Because you couldn't really make the same shape with all those.
So it didn't have the same shape inside of it. Does yours have the same shape?
Unless you use the blue ones, then yeah, but.
So you could either use all the blue ones, or you could either use all the pink ones, but you can't use both. So try it just with the pink ones to make that scaling. Daniel, do you need to go to the nurse? No. Okay. And where's your book? Okay, so you're going to need to borrow and share with Terrence. It's my expectation that you are in this class to work. So if you don't need to go to the nurse and you've got a book to see, you need to be writing things down.
I got this. We're arguing this is on camera.
What do you think of that?
No, it's not. Okay, go get a ruler then. No! It's so smart. I'm not going to waste my time getting a ruler.
Why do you need a ruler? Tell me about it.
She's trying to see. That is an isosceles triangle.
But she says it's an equilateral.
No.
We're doing indirect
Oh
measurement.
wait, this is an equilateral.
So let's look. This one is this side. Oh, that's how long that one is? Is that the same? Done. You don't need a ruler.
I told
Use an
you.
isosceles.
So, which of the triangles fit together make a
So
large
do they
triangle?
all
That's
work?
it.
Yeah.
What?
So now you can definitely start on that.
I
have to. Now I have to draw.
Actually, you are.
You can make it.
Oh,
Here, you can make triangles. That is right now on my step.
All right, ladies and gentlemen, pause. What I've got here is my version of an isosceles. It's really close to an equilateral up here, but I think it will still illustrate our point.
He can make it. Can he make it?
Yeah, can I make it? Oh, remember, guys and girls, in this classroom, when you raise your hand, Caleb, you can make it. Come on up.
Ooh.
As Caleb presents, guys and girls, put down your pencils and give Caleb your full attention. 1 minute. Okay, so if you've got your pencils up, we need to change it to this arrow. I'm sorry about that, Caleb. Yep. And I'm going to start you over. Get rid of this.
Okay,
And
good.
now we're on the arrow.
Let's go.
Oh, thank you to all of those who put down your pencil.
He stole our idea.
Oh, we already did that.
What a cheat.
So, does the isosceles triangle work?
Yes.
Cheat.
What? Could we add another layer down below?
Yeah.
Yes.
Can I do it?
Do you want to try to do it, Caleb? No. Now, we're asking Caleb to think on the fly here. How do you turn them? Ah,
Just
click on it.
like tap on it.
You know, Caleb, actually, I think I'll have you pause. Let's keep that idea, and you can make sketches on your paper. We would have to start off with another row, and then Caleb has keyed into that idea that it's going to have to be turned. Thank you very much, Caleb. Give Caleb a quick hand. Yes.
Now how to make a bigger version of this now? Just figured it out on this.
You did?
Yeah, I did. It's easy.
Tristan, can I have you do the scaling triangle? And Terrence, would you pop up quick and do the right triangle?
Easy. Just figured it out.
Now, guys and girls, throughout Caleb's presentation, you did a pretty good job of stopping, putting down your pencil, and paying attention to it. I'm going to ask that you do that same thing for Terrence.
Oh, does that count as my presentation?
It does count as your presentation.
It is there.
I could have did that.
What?
Oh, so that's how you do it.
Yeah.
That's wrong.
Wrong, just watch. Watch.
I see two squares.
Why is it wrong?
I have no idea.
Go, Terrence.
Need to copy these two. Or copy. Is this it?
I think so.
Ours was a lot quicker.
Let's do.
We only did 4.
Yep, there you go. Brilliant.
Oh, I thought.
It's only 5 squares.
No, just watch.
I'm watching.
We did ours in 4.
What is he making again?
He's making the right triangle, the reptile of the right triangle.
A lot of squares though.
It is a lot of squares. Do you think the scale factor is going to be 2?
No.
It's gonna be a gazillion. It's gonna be Google.
It's gonna be 8, I think.
Be Google.
It's a lot.
Google Earth.
Oh, now I see it.
Yeah.
Not Google Earth.
Except that's a lot of
I
triangles.
see it now.
Can we do ours?
Oh my lord.
Ours is
Look
a
at
lot.
that.
All right, everybody's wowing, but let's be thinking about scale factor.
Look at
What
that
is
shape.
the scale factor of the right triangle that Terrence has built?
5.
Raise your hand if you can tell me.
3.
Raise your hand if you can tell me. Vince.
3.
3. How did I know that, Vince?
Lucky guess.
Lucky guess.
I
Josh,
think it's 5.
do you think it's 5?
Yeah.
Why?
Because there's 5 across that way and 5 down.
There's 5 across and there's 5 down. Dante, what do you think? Based on what you guys talked about. Well, when I was at your table group, we were talking about the scale factor was 2, even though there was 3 across. How much longer is the top of this or the base of that triangle that's up top?
Same.
Vince?
I know somebody got this right. I just didn't. I know somebody did.
Now, guys and girls, lots of people are waiting for someone else to do their work. Think in your heads, what is the scale factor here? How many times longer is that?
3.
Can I write it?
Think in your heads. That was part of your direction. Now, how many times taller is it? Or what's the height difference? On 3, I want you to hold up on your hands how many times longer and how many times wider, or the bases. Everybody's got to participate. We can't move on until we do this. So, we've heard a couple of answers. We've heard 3, we've heard 5. What is the scale factor? Hold it up on your hands in 1, 2, 3. All right. Most people have that it's 3 because it's 3 times longer and 3 times wider. So thank you, Terrence. You may have a seat. Give Terrence a quick hand.
Woo, it's Terrence.
Now,
super smart.
guys and girls,
My shapes.
ladies and gentlemen, eyes up here. You now have enough information that you can continue this problem. But before I set you free, how many times greater is the area on this one? Don't shout it out. Chester?
9.
9.
Never
1, 2, 3, 4, 5, 6, 7, 8, 9 times the area. So we stretched it out 3, we stretched it out by times 3, and the area increased by 9. I'm going to hold off on your presentation for now. I'd like you to get back in your groups, and you need to be on the same part of the same problem. No one may move ahead. You need to pull that person that's a little bit slower with you.
Get it together.
Vince. A through C is your job today. Everybody needs to be working on A through C. Off you go.
I'm walking here.
I got to fill out my purple sheet.
The other shape. Go ahead and work with just the 2 for now.
So I'm gonna be scaling
Yes.
around you guys. Right, B.
Do you like
I got hit by a car yesterday.
Are we gonna watch this?
We might. But, letter A. What does letter A say?
Which of these triangles fit together to make a larger triangle that is similar to the original? Make a sketch to show how the copies fit together.
All right. So, on your paper, please do that. Let's take these out, Dominique, because it's going to be too hard to have them both.
Can we use graph paper?
You can?
Okay.
You can set that
I'm gonna like tear the front and back off so then I have to very easy. Like pull the pieces off. So it's each of these triangles?
Yep. So we're looking at the scaling, we're looking at the right, and we're looking at the equilateral.
Do we just
Daniel? Letter A?
Something like that.
Do we just pick one of those or
You can work with the ones that you know about.
I'm gonna use the one that just did that.
It's close. What do we look at your sketches from question 8? What was the scale factor? Okay, so at this room today,
There's the areas. What's the scale factor? What, no, what's the scale? Oh, I see.
Every question. So you want to do me and Aaliyah?
The scale.
Aaliyah, Jaden?
Scale.
This is Tyler and Caleb.
We're doing
So,
correction.
now that you know at least each other's names, it is the expectation that you are working on the same part of the same problem. Write about the triangles that you know about, because we only have about, I don't know, 16 minutes left of class today. So, letter A. Caleb, will you read it out loud? And I'll steal this from you.
The first one.
which of these triangles fit together to make a larger triangle that is similar to the original?
Right. This is the
Make
right
a
triangle.
stretch to show
Oh my God,
how
I am on it.
speed together.
That should be the right triangle. No, this one's right. That one.
There, buddy.
These kids.
What is the scale factor of each original triangle with each
So based on the sketches that you made in letter A, what is the scale factor from? So I see,
That's not good. This is
Why are we always working with scale factors?
well, our goal of our unit is understanding similarity, and scale factor helps us understand similarity. That one is the right triangle. Now, guys, I want you to be thinking about letter B1. What is the scale factor from each original triangle to each larger triangle? Okay. So you made some sketches, and I see, Amelia, that you have some work done. Why don't you share that with your table mates so that you guys can write it down?
Do you have any erasers? I need
Is
erasers.
this how you share? It's okay. What? We have to regain to the same part of the same problem. Okay. So it's 2 times bigger, so the scale factor would be 2. Is that what Emilio has too? Confer. Make sure that you're talking to each other. What do you think it is?
5.
Okay, Vince, will you be serious, please?
Yeah. 2.
Okay.
We have an agreement. Right triangle, we think right triangle is green. Do you agree or do you disagree?
Do you mean right and
triangle
isosceles?
is 3.
I'm ready.
What is the skill factor?
How do you know the area for this one? And then we have to find the area for the original image.
You do. So let's say, just for example purposes, that the area of this is 1. What would the area of the larger be? Or how many times greater?
How did stop people are married?
4. Is this scaly?
Oh my god, it's broken.
This one be 1.
3.
You can use the original, whatever it is. This is 1 copy, so its area is, if let's say it's 2, but then we have 4 of them, we go from 2 to 8, and so that'd be 4 times. So if you think about this as 1, that's an easy reference. We're more thinking how many of the original copies fit inside it. Now guys, make sure that you're on the same part of the same problem. So just compare a little bit ahead, will you pause and see what these guys are up to?
What?
Time.
How is
3.
Choice right now does not work. How come? Okay. Would you rather do this working all the way by yourself? Because the next step would probably be the office. So to get that out there, that you work in this class or you don't get to be in this class. So I'm going to give you a chance to make that choice. We've been in this class for almost 20 minutes though, and you need to have something on your paper. Show me about your thinking.
It took me like 3 minutes to walk all the way.
9. Now see what? I'm on C. Are you guys on C?
I'm a slow walker besides that my walkers.
Guys, are you on topic? I don't think your locker has anything to do with similar figures. If we built lockers sideways and up, maybe we could make a similar figure, but we're dealing with triangles today. So you're saying what?
I say it goes by 3.
Which one?
I think it's halfway too though.
1, 2, 3.
Which one? Are we talking about the equilateral or the right?
Both.
Both. So when you built this before, if I remember right, it was like this, and one more on top, right?
I need to erase this shit right
Say 1, 2, 3. Times that by 3.
If we time, let's say for example that the area of this is 2.
Times by 3, you get that.
So let's just say that the original area of just one shape is 2. What would the area of the new shape be?
4. Oh, 8.
So how many times greater would it be?
2. Told you. It's 2.
Wait.
I think it's 2. Still think it's 2. So it's 2.
So are we talking about the scale factor or the area?
Both.
Are they going to be the same?
No, one's going to be 2 times bigger than the other.
So if the scale factor is 2, then the area is going to increase by
2. So it's 4.
by another 2. Okay, so because we're stretching it. Devin, does that make sense? Because I'm a little bit confused.
Multiply by 2 and 3.
Yeah.
Told you.
Oh, we're supposed to draw bigger.
So what if the scale factor is 3, like in
What do we have to draw? Oh, you can't make
Terrence's
a
example?
triangle.
Yeah.
Yeah, but
Then it would be 9 because we go 3 times 3.
What kind of
What if the
triangle?
scale factor is 4?
And then it's going to be
8 or 16, Devin?
Wait, hold on.
Oh, wait.
If it's what? 4?
So if it's 4, we're stretching it times 4 this way, and we're stretching it by times 4 this way.
16.
So you're going to fill in with 16 original copies.
Yeah. And this
Wow.
one is 4 original copies. Wait, it's by 2.
So if the scale factor is 2, then 4 original copies fit. Okay, keep going, guys. You're on the right track.
Told you.
I think I got that when she first said it.
The more we talk about it, sometimes it
I told you it
gets a
was
little
2. You said it was 3. It's 2.
All right,
It's
Mr.
2.
Tyler, where's your notebook?
Yeah. Peace.
You gotta have it, kiddo.
Okay, there you go.
Because the only way that you can stick with your group and be with them is to have
Knock
them
3
with
of them off.
this one up here.
That is the right angle.
So I'll hold your place.
That's the
You flip
right
it out,
angle.
flip it in.
This is the isosceles angle.
This?
These are isosceles. This is right. How many times have we done it? Right there.
Are you guys all in agreement with what? Whoa, wait a second. How can you talk about a problem if you're on different problems?
See, it's right.
Is talking about a problem important? So, Jaden, you gotta make a strong effort here. You gotta take a leadership role in this group too. Slow Caleb down. Tell him, hey, we're supposed to be on the same part of the same problem. Can you do that,
Make
Jaden?
sketches out of a triangle fit together. Oh my
Tyler?
lord.
Have you said anything to these guys today? Nope. Okay, that's your job. You gotta say, wait up! You've been working really well in class. I did it for this new group. So you gotta settle into this new group. The expectation is that you're all on the same part of the same problem.
I sent coffee a long time ago to the teacher meeting.
What's your second name?
Didn't say my name.
C3.
Make sketches to show.
Find the scale factor from each triangle, from each original triangle to each new triangle.
Find the scale factor from each original triangle.
Now C4. It's 3.
Hold on.
3 because it's because I'm
Should you? Yeah, no.
okay. Yeah.
So pause.
Find the scale factor from each original.
What?
3 because. A triangle has 3 sides.
Do you agree with what you just said, Caleb? What I don't see at this group is that you're listening to each other. I see that you're giggling and working with each other a little bit, but it's kind of like you're faking it.
Fake?
Faking. What you just said, they didn't listen to. What you just said, they didn't listen to.
What I say then?
So, guys, you're goofing around too much. Emil, pause. Listen.
Is that right?
You, Vince, you're goofing around too much. You need to listen to each other and to think about what each person says before you move on.
Yep.
So, the giggling that I'm hearing from across the room isn't productive. This is not productive group work. You guys know what that is like. You've all been in good groups. Slow down and listen to each other. Don't make jokes with each other. Okay? Off topic.
C4, explain what the scale factor is. What? Okay.
I
Because triangle is 3.
Okay, talk to your group. Not about inventions, but about which one
Explain
you
what
stuck
the scale
with.
factor
Then I'll
is.
stop back and help you.
From side length. All are
It's
times.
about two.
It was this one was, I tried it already,
Mm-hmm.
and I just like didn't have it, so I just put
Let's end with that one. Go ahead and skip it for now and move on to letter B. So, Dominique, you can skip it too. Move on to letter B. Terrence, will you do that again, but this time out loud? So that these guys can hear you? Yeah.
for reading.
Yep.
What is the scale factor from each original triangle to each larger triangle? Explain.
So in your sketches, you have two really nice sketches here. You have a couple really nice sketches, all of you do. What is the scale factor from the original isosceles triangle to the new one?
2.
2, okay? So maybe write that right below it. That would be fine. Scale factor 2.
And then this one, the scale factor is 3.
Do you guys agree? Daniel, do you agree that on this one that Terrence did on the board that the scale factor is 3? Dominique, do you agree? Sure or yes? Okay. So now go ahead and go on to B2. You got about, that's probably your last question you'll get to today. No, not on the stage. That's how you use this.
Okay, how is the perimeter of the triangle related to the perimeter of the
They didn't answer me.
They didn't.
Oh, well, he thought it was.
You thought the perimeter might be times 2?
Yeah, either time.
Why do you
I
think
think it's
that?
times 4.
You think it's times 4?
Because each one you use 4 to make.
You do use 4, but how many extra side lengths do we get?
Oh, we only get 1.
We get
2.
2 off of each, don't we?
So it's
So,
times 2.
so we've got 2 here, and 2 there. So it's times 2.
Yeah. So would this work?
Would you guys come up to the board to finish off our class and share your scaling one?
Yeah.
Joe, Chester, and Tristan, you guys can all come up, or just one of you can come up. But we'll close up our class that way. We're done. Come on up.
But there's 4.
All right, guys and girls, we've got 2 minutes left in class. We've got this crazy scaling triangle. We need to know. I made it. So, guys and girls, I will dismiss you. The bell will not. Please focus and pay attention so that they can show you their design. Oh my God! I made it.
I made it.
Whoa, how do you spin the color?
All right. Let's instead just turn our heads towards where Tristan was sitting. That scaling triangle does work.
I made one.
When we come back tomorrow, oh, I have people moving around. These guys are the only ones that should be standing.
I can't see that far.
When we come back tomorrow, we'll talk more about perimeter. When we're thinking about scale factor and area, it goes back to this poster over here. The area is the scale factor times the scale factor bigger. So if the scale factor was 2, 4 copies fit inside. When the scale factor was 3, 9 copies fit inside. When the scale factor was 4, how many copies would fit inside?
16.
We're going to continue with this idea tomorrow. You may clean up.